My name is Steve Cook from Norconsultestando. And while you've all been in here during this fantastic conference today, we've had a wonderful team of students from the IT Gymnasiet, the IT college, just up the hill here, who have been knocking their heads together in a hackathon around machine learning. And the hackathon today has been organized by Malin Ulvason from Chalmers and by Erik Isaksson from the IT Gymnasiet. Thank you to you both. And the students have been working here for a couple of days. We gave them a challenge a week ago. And then they've been working yesterday and today producing solutions which will produce an innovative solution that contributes to the UN Global Sustainability Goals with the help of machine learning. And I'm sure you'll agree that's a very high bar to cross. So the 6 teams that we have between us, the participants are aged between 16 and 18. And they've all produced a wide range of different solutions to this challenge. We have solutions dealing with revolutionizing human learning through machine learning. Is it clean? Analyzing water quality. We have a solution called FEED, reducing food waste in schools. Then Teacher's Pet, aiding teachers to maintain quality and focus in classes. Återvinnarna, automatic sorting in waste recycling systems, and Sustain Ads, targeted advertising for charitable goals. So they've produced amazing solutions, and our jury today, we've a jury of 4 people, Jörgen Larsson from Business Region Göteborg, Oskar Iversson from Chalmers, who's a data science application expert, and Snežina Racheva from GU, from Control Alt Team, and Angeliki, who you saw here on stage earlier from Google DeepMind. And I'd like to point out that the jury commented that the quality of the competition today and the quality of the submissions that they've seen was absolutely outstanding. So a big applaud to all of our teams. But now I have the moment when I have the winning decision here, and I haven't seen this before either, so this is news to me. And the jury's motivation is that this team provided a solution to a global problem that is truly globally accessible. With a clear idea and good application of machine learning, their result is a small product with a big impact. It provides an automatic solution to a problem which is hard to solve manually. We can't wait to see where the future takes this project. And the winning team is the team Aqua Squad. Congratulations. Here we go. Oh, and these are going to all come out in a bunch now. So we have some small prizes for you guys. So thank you, and thank you, and thank you, and thank you. And let me grab you some microphones, because now we're going to all get to see the winning team's winning pitch. Okay, and we connect this up to the computer here.
Water, covering a total of 70% of the Earth's surface, but only 1% of all of this water is actually suitable for drinking. Water is a necessity for human survival. On average, you can only survive up to 3 days without water. Out of the 17 goals for sustainable development set by the United Nations, we have focused on goal number 6. Ensuring access to water and sanitation for all. Every 10 seconds, 1 human life dies due to dirty water, often due to diseases such as diarrhea, cholera, or dysentery. We have made a prototype of a mobile app that by both analyzing a picture and a chemical sample of the water that you intend to use can decide to which extent this water actually is clean or dirty. And after having come to this conclusion, the app can also suggest what you should do with this water. Maybe it's safe to drink, maybe you should boil it, or maybe you should filter it.
With the power of machine learning and Google's APIs, our product is capable of telling apart clean water from dirty water. It can predict if the water is contaminated with chemicals or plastics and give a prediction whether or not it's capable to drink. A voice user interface is used to communicate with the app. Access on Google, together with Dialogflow, is used to recognize the voice of the user and respond appropriately. Finally, using Google's AutoML, the real product could learn to distinguish clean water from contaminated water using pictures. Now, let's demonstrate a prototype of our product. Okay, Google, is it clean?
All right, getting the test version of Is It Clean? I'm ready to analyze water. Please upload an image.
Okay.
All right, analyzing image. By the way, did you know that 70% of the human brain is water? Oh, it seems like the image analysis is done. The result is on your phone. Would you like to further analyze the water?
Yes.
All right, use the detector to check for any chemical contaminations in the water.
Okay.
Great, the final results are displayed on your phone. It seems like the water is clean and you can drink it.
Thank you for listening. So, any questions? Yes.
How confident are you of the predictions of your system? Would you drink the water if it says it seems clean?
Sorry, can you repeat?
How much do you trust your system? If it says it seems clean, will you drink the water?
Well, it's a probability, so based on that, I take the decision.
Which features did you use for the water? Like, what kind of features are you using?
Sorry, do you mean with the machine learning?
Yeah, the pictures.
So this is only a prototype, and we had we can see if we can get it to work again, but we haven't actually got a fully working system because we've only had 2 days, and it would be quite hard to.
Yeah. We're thinking of feeding the machine with tons of pictures of dirty water, of clean water, of water with soap in it, water with algae, bacteria, and so on. And all of this will add up that it can actually, with accuracy, place it where a picture belongs based on, well, the scale between dirtiness and cleanliness.
So deep learning can be like a magic box, and the more data you feed it, the better it gets.
Okay, great. So do I understand correctly? Do you make the judgment of the water quality based only on the picture of water, or do you also use some chemical analysis as data input and so on?
Yeah, we have a sensor that we use to detect microplastics and such.
Heavy metals, bacteria, and other things that aren't visible to the eye, and that's why we used both picture recognition but also chemical analyzing to, well, be sure that this water is actually clean, although it might not seem, or it might seem at first, but it actually isn't.
Okay, I think this is a great time to round off and I think I'm sure you'll join me in congratulating our young team here. Congratulations, guys.